Hi students, this video is a continuation of the previous video, and in the previous video we have learned sharing, and we have learned 2D sharing, and since it is 2D sharing, I can perform sharing along x axis and I can perform sharing along y axis, right? And you know sharing is changing the shape of my object, right? And we'll continue with sharing along y axis. In the previous video, we have learned sharing along x-axis. Right? If I perform sharing along x-axis, there will be a shift in horizontal direction. Here in sharing along y-axis, there will be a shift in vertical direction. There will be a shift in vertical direction. Now, coming to this equation, x value remains the same in sharing along y-axis and changes will be in y value. These values I have to represent in matrix form. Right, here you can check x coefficient is 1, there is no y value, so it will be 1 0, and here y coefficient, here again x coefficient is shear y and y coefficient is 1, so it is shear y 1. Right, and now we can represent this 2D sharing in homogeneous form. Right, homogeneous form, you know, 2D values, I'll write in triplet value. Right, so I have written a 3 cross 3 matrix for sharing along y-axis. Now we'll continue with this inverse and 2D composite transformations. Right, we have learned the basic transformation like translation, rotation and scaling. Now in this video we learn the inverse transformation of those basic transformations. Right, you know the transformation matrix of translation. Right, this is the um, translation matrix in homogeneous form. Now I have to find the inverse translation, right? And you know Tx and Ty are translation distance along x-axis and this is translation distance along y-axis, right? You can inverse it. So in the place of Tx and Ty, I'll write as minus Tx and minus Ty. This will be my inverse translation matrix, right? Coming to rotation, this is the rotation matrix that we have learned already. Right, this rotation matrix I have written in homogeneous form. And now I have to find the inverse rotation matrix. For this, what I have to do is like substitute minus theta value everywhere. Right, so you know cos minus theta is cos theta. Right, and sine minus theta is minus sine theta. So that minus plus this minus becomes plus here. And here sine minus theta is minus sine theta. So I got minus sine theta. Here cos minus theta, again it is cos theta. Right, this is my inverse rotation matrix. Similarly, we can find the inverse scaling matrix. This is the scaling matrix in homogeneous form. How to find this inverse scaling matrix? Just inverse it. In the place of Sx, I have to write 1 by Sx, 1 by Sy, remaining everything is same. This is my inverse scaling matrix. Right, now we can see composite transformations. Composite transformation is sequence of transformation, performing sequence of transformations. And why I use this composite transformation is like to perform the product of matrix. To perform matrix multiplications, I'll be using this composite transformation. Right, first I'll see what happens when I do successive translations. This is my point P. You know translation is nothing but displacement. Right, and this Tx and Ty is translation distance along x-axis and Ty is translation distance along y-axis. So to this point, first I have to perform translation and again I have to perform one more time translation. Right, and you know composite transformation is performing sequence of transformation. At the same time I can do matrix multiplication. So you know how to write these homogeneous translation matrices. I have written for both the translations. When I perform matrix multiplication, I'll be getting this as the result. Now check this result. What does this result says? T1x plus T2x. This T1x is the first translation along x-axis, translation distance along x-axis. T2 is this second translation distance along x-axis. So when I perform the matrix multiplication, the result shows I can add it. So I can conclude successive translation is additive. That is, instead of performing 2 times translation, I can add all the translation distance along x-axis and all the translation distance along y-axis, and I can perform translation once. Right. Next is composite transformation for successive rotation. Right. In successive rotation also, instead of performing 2 times successive times rotation, what I can do is like I can add all the angles and I can perform rotation only once. So I can say successive rotations are additive. Successive rotation is additive. Similarly, when I take successive scaling, this is the scaling matrix, right? For the first scaling, second scaling, when I perform the matrix multiplication, this is the result I am getting. From the result, I can understand, right, that successive scaling is multiplicative. Instead of performing scaling successively, what I can do, right, scaling factor along x-axis, I can multiply all the scaling factors along x-axis and I can multiply all the scaling factors along y-axis, perform scaling only once. Right. And next case is under composite transformation is 2D pivot point rotation. Usually rotation happens with respect to origin. Now suppose if I want to perform rotation with respect to any selected point, any pivot point, what I have to do? What are the composite transformation? What are the successive transformation that we can see in this case? Right. So what I can do is like this pivot point I have to move to origin. Right. Pivot point I have to move to origin. That is my first step. Right. Pivot point I have moved to origin. Next it is, as the case says, pivot point rotation. I will be rotating with respect to origin. Next I have to move back this object to its original place. That is inverse translation. Right. So moving is the corresponding transformation is translation. Right. I am moving in opposite direction. I am moving in opposite direction. So this will have, right, this will have this negative x and negative y. Then I am performing rotation and at last again I am moving back to its original position, that is inverse translation. Right, this is the inverse translation matrix. When I perform multiplication, this will be my result. What is this fourth case? I have to find the successive transformations when I do pivot point rotation. Usually I will rotate with respect to origin. Now if I want to rotate with respect to any pivot value, these are the steps. And the last case is 2D pivot point scaling. You know, scaling is changing the size of my object. Now pivot point scaling. Right, I have to perform scaling with respect to this pivot point. So what I have to do, move this object so that this pivot point coincides with your origin. Move the object so that this pivot point coincides with your object. Then perform scaling. Then move back the object to its original position. Right, these are the steps. So first, since I am moving in opposite direction, right, it will be the translation matrix, it will be negative values, then scaling and at last inverse translation. Right. So in this video we have learned inverse transformations and composite transformations. Thank you.